All right, in this video, we're going to talk about two-tail hypothesis tests for populations for the mean when the standard deviation is known. So this is also an example that's taken out of your book. And for this example, the book is telling us that the Wall Street Journal has an article claiming that the average American spends 36 seconds looking at a web page. A researcher at a local university would like to test this claim using a hypothesis test. And suppose that they take a sample of 60 internet users that spend an average of 47.3 seconds looking at a web page. Assume the standard deviation for the population is estimated to be 32 seconds based on previous research. All right, so let's set up this problem. I've written everything out so we can go through and fill in the blanks. So identifying the null and the alternative hypothesis. So we know that status quo is that WSJ is claiming that the average American spends 56 seconds looking at a website. So conversely, we know that the alternative is they do not spend 56 seconds. Like I said, it's either they do or they don't. It doesn't matter if it's more or less. So setting the value for alpha. So the significance level. So for this example, if we're saying the significance level is going to be alpha is equal to 0.05 again. So 0.95%, but 0.05 for the probability of having a type 1 error. Okay, so then because this is a two-tailed test, right? And by two-tail, we talked about this earlier in the chapter. This is mu. If it's equal to or not equal to, is a two-tailed test. So we know this alpha is going to be split. So it's going to be 0.025 on this side and 0.025 on this side because it's symmetrical. So this is z-score of alpha divided by 2. And that would be the z-score of 0.025. Sorry, 0.025. And that is equal to, if we look that up in the table, that is going to give us a 1.96 for the appropriate critical value or z-score. So z-score associated with 0.025 is 1.96, right? So calculating the appropriate test statistic. So in order to do that, we know that z is going to be equal to x bar minus mu of h naught divided by the standard deviation divided by the square root of n, right? So that's going to give us our 47.3 minus our 56 divided by our 32 divided by the square root of 60, which gives us negative 8.7 divided by 4.3. And that gives us a negative 2.11 in terms of our our appropriate test statistic. So now if we go on and we want to compare the test statistic, and in this particular situation, I'm looking back at what we have on in table 9.3. So let's compare. So the table tells us we have when our z-score was equal to 0.196, and this is our negative 0.211. Oh, I'm sorry, 2.11. Sorry, let me just erase that and write it the correct way. Getting ahead of myself. And that's a negative. But when we're looking at our table, it tells us that we're also going to take the absolute value. The table also tells us that if our test statistic is greater than our critical value, that we reject H naught. So in this particular situation, we are going to reject H naught, meaning that the other thing, well, I won't get into that, meaning that somehow this falls into this area. The number of pages actually falls into this area, right? So in stating my conclusions, I can say that and I guess this is the since I'm rejecting H naught, I can say that the average amount of time spent on a web page or looking at a web page is not equal to 56 seconds. So this substantiates what the researcher is claiming, is that the amount of time looking at a web page is not equal to the 56 seconds. He's claiming that it's 47.3 seconds. So this substantiates his claim. So I hope this is helpful. I'm going to come back and do one more video on P-score for a two-tail test. When the population, when the standard deviation is known. And if you have any questions,